Bayesian probability comes from Thomas Bayes, a mathematician and theologian who lived in the 18th century. He was the first person to use what is now called Bayesian inference to solve a difficult statistical data analysis problem. Bayes' theorem is one of the most prominent ideas in Bayesian probability theory. It tells us how likely something is to happen based on what we already know about conditions that might be linked to the event. Thomas Bayes, who initially formulated the theorem in the 18th century, is honored with the naming of the mathematical concept. However, the contemporary formulation of Bayesian probability theory is credited to Pierre-Simon Laplace. Laplace was the pioneer and popularizer of what is now known as Bayesian probability, and he's credited with developing the theory.
This is the Sundeep Show.
I like this Bayesian probability. Why I like this idea of this probability is because you don't have to worry too much. Today, we have so much information. Too much information. It is obnoxious. Sometimes it feels like a pile of garbage. Just when you think you have enough, then something else comes along and then gets piled up. And that might make you want to change your take on something. It can be frustrating. Yes, new data is always welcome, but there comes a time when you want to say, enough is enough. It is basically asking you to be a little bit of a human being, not be a calculator, where something is fed and you give out a precise calculation. Bayesian probability gives you either a hit or a miss, or sometimes even both. It's a win situation, it's a loss situation, and sometimes it's also a win-win situation and loss-loss situation. I believe this probability still respects the gut. It allows you to factor in your intuition, your strong feeling from inside, based on whatever you know, based on how much ever you know so far. In other words, it's asking you to be responsible for the decision you're about to make. I think it's a fair ask. A different perspective on probability than the conventional or frequentist one is provided by Bayesian probability. Bayesian probability differs from other probability frameworks in that it does not quantify the frequency of occurrence over an extended series of repeated trials. Instead, it assesses the level of confidence that an assertion is true in light of the evidence at hand. The problem I have with the frequentist view is that it fights for uniformity and patternized anomalies. It fundamentally opposes uncertainties and unpredictabilities. It is a black swan hater. Human error makes way for a black swan. A little bit of human error here, a little bit of human error there. That's what gives you a black swan, eventually, or suddenly. But when there is data that's harnessing the emotion, your instinct, your own internal research, that whole thing kills the spirit of serendipity. There are numerous applications for Bayesian probability, including the verification of medical diagnosis, the revision of weather predictions, the analysis of sporting events, and the formulation of decisions in the face of uncertainty. Bayesian probability can also deal with real-life situations that are complicated and include more than one hypothesis, more than one source of data, and different levels of certainty or reliability. One of the benefits of using Bayesian probability is that it enables us to express our uncertainty in a clear and consistent manner, in addition to allowing us to factor in past knowledge and subjective opinions into our deductive reasoning. But one of the difficulties with Bayesian probability is that it necessitates selecting a suitable prior probability, which isn't always clear-cut or simple. Moreover, Bayesian probability may occasionally produce unexpected or contentious outcomes, which may contradict frequentist probability. When dealing with scenarios that involve ambiguity, inadequate data, or the need to update beliefs in light of new knowledge, Bayesian probability is particularly useful. It offers a logical structure for managing ambiguity and arriving at well-informed decisions by combining known information with empirical evidence. Thanks for tuning in. I'm Sundeep August. This is the Sundeep August Show. Bayesian probability, to me, is like a hippie. Do good with what you have. Yeah.
This is the Sundeep Show.